Greetings to you, viewers. Welcome to our class, King G tutorial. We shall be considering the subject chemistry and the topic Gay-Lussac's law. Gay-Lussac's law. I really wanted to take care of this question, but there is no way we can consider this question without, having a flashback on the topic Gay-Lussac's law. Gay-Lussac's law states that when gases react, they do so in volume, which is in simple ratio to one another and to the volume of their products, provided temperature and pressure remains constant. What are we saying so far? When gases react, let's assume we'll have hydrogen gas reacting with oxygen gas to produce a steam, right? That's what we have here. This all are in gas form. Balancing this is a gas, this is a gas, this is a gas. All right. When these gases react, they do so in simple volume, or rather is in simple ratio. Like bring up the very ratio of this ratio, mole ratio, right? Mole ratio of this will have hydrogen to be what? How many here? The mole. Okay, this number of mole. Okay, taking you back to number of mole, like you may have sodium. This is sodium, all right. This is one atom of sodium, but if you add two here, this is 2 moles of sodium, and you can also call it two atoms of sodium. But this number here signifies what? The number of mole. So this give us what? 2 moles of hydrogen gas. So we have 2 moles, all right. Two, this mole ratio, mole ratio, mole ratio. So 2 moles of hydrogen gas is reacting with how many hydrogen gas? O2 is the gas, okay? So we have what? One mole of oxygen gas to give you what? 1 mole of the steam. Sorry, 2 moles of the steam. This 2, all right? 2 moles of this. Now, when you look at the numbers very well, they are simple ratio. What do I mean by simple ratio? You cannot further break this down, as nothing can divide this. Just having let's assume you have 1/2. Okay, this is the in its lowest form. Okay, but if you have 2/4, it means that you need to still go ahead to split it down. So this the simple ratio of this become what? 1/2. Or you have 3/6. 3/6 can be broken down to 3 here 1, 3 here is 2. Okay, see, this is what 1/2 is a simple ratio. So this mole ratio, this ratio is in simplest form, as you can see, according to Gay-Lussac's law. And this ratio are also the volume, okay, of the gas are taken as the volume of the gas according to Avogadro's law. So they have what? Simple ratio to one another and to the volume of their product. So this, if this is 2:1:2, it is something as having what? 2 centimeters cube by volume going with 1 centimeter cube of this to 2 centimeter cube of this, which is the 2:1:2. See how it is by volume. Okay, so having known this, we can go back to our question. Remember what I stated as Gay-Lussac's law. All right, the question we have here says 50 centimeter cube of carbon 2 oxide carbon 2 oxide and 30 centimeter cube of oxygen were allowed to react. Okay, we have to calculate the composition of the resulting gas. All measurements being made at the same temperature and pressure. Remember, Gay-Lussac's law states that the temperature and pressure are constant. So going into our question at this moment, we have to react this carbon 2 oxide The formula is what? Just O2, right? O2. You have to react with the oxygen here, and it should be in gaseous form, which is O2, right? So carbon 2 oxide is reacting with the oxygen gas to produce what? Carbon 4 oxide. Now coming to balance of this, we have two oxygen here. Yes, we have two oxygen here. Yes, we also have this here. Okay, all right. So at this point, we can still go with this three oxygen. Three oxygen is a 2 here plus this three, right? So in order to balance it up, I can decide to go on with two here. So that I will have two oxygen give us four oxygen here. Okay. No, and now our carbon becomes two. To balance up, you have two divided by one of it here being what? Two. So I can add up two here. So at this point, we have two carbon here, four oxygen here. That is 2 plus 2, 4, and then 2 times 2, 4. You see that our equation is balanced. Now going to our mole ratio. By mole ratio, the ratio of this. By our ratio of reaction, we have 2, right? 2 moles of carbon 2 oxide reacting with 1 mole, okay, 1 mole of oxygen to give us 2 moles of carbon 4 oxide. So the mole ratio here is giving us what? 2 ratio 1 ratio 2. Okay, now by volume, it becomes what? By volume, it becomes 2 centimeter cube going with 1 centimeter cube to give us 2 centimeter cube. It means that for the gas to be produced, you will need 2 centimeter cube by volume of carbon dioxide to react with 1 centimeter cube of oxygen gas to produce 2 centimeter cube of carbon 4 oxide. All right, to the equation, let's see what we have here. We are given 50 centimeter cube in this equation, in this reaction, of carbon 2 oxide and 30 centimeter cube of oxygen, okay, gas. Now I want to explain something here. When it comes to this, we work based on what we call limiting reagent, limiting reagent, reagent, and excess reagent. What do you mean by these two? Let's take for an example. We are producing um we are producing we are producing peanuts. Yes, where I will need my flour. And let me assume I have three cups of flour. This is the cup of flour, 3 cups, and also have granules. Okay, like having uh 5 balls of granules. Okay, so I will have to produce this. I will take my flour, take up this. Okay, so I will produce one. This is giving me one, that is a flour, cup of flour and granite, producing one. Another flour, granite taking two. Another this finish. Okay, with this now I cannot further produce this. Why can't I produce more peanuts? Because the number of flour has finished. I do not have any other no, flour to produce more, but I still have granite remaining. So at this point, because this flour has finished, my flour becomes what? The remitting what? Reagent. And the one that is remaining becomes the excess reagent. So what how do I define this? I can quickly say in a nutshell that remitting reagent is that reagent that got finished, okay, during chemical reaction. while excess reagent is the one that is left untouched, okay, at the end of the reaction. So at this moment, we need to make sure you use the volume of these gases as we were given. You discover that after this 50 volume given, 50 and 30 given, we will not use all, okay, but what we need to follow is this principle, that following the principle of this common ratio, we will have to share this 50 to work into ratio 2 ratio 1 ratio 2. All right, that is, first of all, consider, since we are given carbon carbon 50 centimeter cube by volume and oxygen to be 30 centimeter cube by volume. Are we to use all? No, we cannot use all. Following our common ratio of the volume 2 ratio 1, what we need to do is, which way do I express this 30 and 50, so that when I divide them I can still get 2 ratio 1, 2 under this and 1 under this. I will have to think, which one do I do? Note, don't increase any of them, but the only thing you can only reduce, so as to get this volume, the common volume. Okay, so to me, I will look at it here very well. If I should decide to use out of 30, if I decide to use 25 out of 30, I think it can go. Yes, if I decide to use 25 out of 30, just like if one gives you money to get to buy something, you can decide to use part of the money. Okay, maybe you buy some, and whatever that remains, you return the change. All right. So here, out of 30, in order to obey this 2 centimeter cube ratio 1 centimeter cube, I will decide to use 25 so that it will go. Now, but note, there is no other way I can use 50 if I want to reduce 50. If I reduce 50 by anything, I cannot get 2 when I divide. I cannot get. So there's no need of you touching this one. And there's no need of you cannot increase any of them. You cannot increase. Take note of that. So on this now, I have decided to use what? 25 out of 30. So with this now, 50 will still remain. And I will say my 50 is still there. Okay, volume used my volume used is what? 50 centimeter cube is retained, and here I am using what? 25 centimeter cube. Okay, now having this, if I divide 25 divided by 25 is 1, which is this, and 25 going to 50 is 2. Okay, you see, you've gotten it. And now, because this is 2 ratio 1 ratio 2, this is 2, this is 2, it means that this other one should also be what? 2, should be what? 50. Sorry. Okay, so that if 1 is equal to 25, 2 will be what? 50. I think we have gotten something here. Now, going back to the question. Question says, calculate the composition of the resulting gas. The resulting gas is what? 50. So here we have volume. Volume. Therefore, volume of the resulting gas is equal to 50 centimeter cube. Now, our question might be volume of the unused gas, or the leftover or residual. All right, okay, volume of gas not used. Okay, volume of, okay, can we also use excess, okay, excess reagents. All these are questions that will come, so you take note on how to answer this. So it will come what? Out of 30, we are given 30 before. You have 30 minus what is used is 25. all in centimeter cube. All right, this will give you 5 centimeter cube. All right, this is how we approach this kind of question that has to do with what? Gay-Lussac's law. Just understand this very well. It is very easy to do. Here, the question we ask here is what? Volume of the resulting gas, calculated as what? 50 centimeter cube. Where this one I just have to add it up. We are not given, I have to add it up should in case you come across it anywhere in your exams. So that is all for now. Do click the like button, share this video to your friends and well wishers for them to learn from this. That is all for now. Thank you for paying attention to our class. uh Goodbye for now.